Permutations question 11. A church has 7 different bells in its bell tower. Before each church service, 5 different bells are rung in a sequence. How many possible sequences are there? So when we hear the phrase how many, we want to think multiply. So there's 7 bells in the bell tower, and before each church service, 5 different bells are rung in a sequence. So I've drawn out 5 boxes. The first box represents the first bell, the second box represents the second bell, and so on down as far as the 5th bell. The phrase how many makes us think multiply, so I've got multiplication symbols in between each of my boxes. So there's 7 bells to choose from, but only 5 bells actually get rung before the church service. So for the first bell, we have a choice of 7 bells. Now it specifically says in the question that 5 different bells are rung in a sequence. So whatever bell we used for the first bell, we can no longer choose that one. So if there was 7 to begin with, we've used 1, 7 take away 1 leaves us with 6 bells to choose from for the second bell. Because remember, they must be 5 different bells that are rung. So we've 6 bells to choose from for the second bell. In the same way, for the third bell, we've used 2 of the bells already. So for the third bell, 7 take away 2 leaves us with 5 bells to choose from for the third bell. For the fourth bell, we've used 1, 2, 3 bells already. So 7 take away 3 leaves us with 4 bells to choose from for the fourth bell. And for the 5th and final bell, we've used 1, 2, 3, 4 bells already. So 7 take away 4 leaves us with 3 bells to choose from for the 5th bell. So 7 times 6 times 5 times 4 times 3 gives us 2,520. So there are 2,520 possible sequences of bells. Or we could have put into the calculator 7p5, and again that gives us 2,520. So we've 7 bells to choose from, but we're arranging them 5 ways. Now if the question had left out this word different, if it had said before each church service 5 bells are rung in a sequence, if it had left out the word different, meaning that some of the bells could have been repeated, it would have been 7 times 7 times 7 times 7 times 7. But because it included the word different, we had to keep subtracting 1 each time so that we didn't repeat any bells. Permutations question 12. 1. In how many ways can the letters of the word modal be arranged? 2. How many of these arrangements begin with L? 3. How many do not begin with L? And 4. How many end with M? So part 1. In how many ways can the letters of the word modal be arranged? So first of all, the word modal is 5 letters, M-O-D-A-L. And we hear the phrase in how many ways, so we want to think we're going to multiply. So there's 5 letters, so I've drawn out 5 boxes. The first box represents the first letter, the second box represents the second letter, and so on, down as far as the 5th box represents the 5th letter. So in how many ways can the letters of the word modal be arranged? So because it says how many, I've got multiplication symbols in between each box. So we start off with 5 letters to choose from for the first letter. Once we've used the first letter, it doesn't matter which one it is, let's say we use the D, then we have 4 letters left to choose from for the second letter. Once we've used 2 letters, for the third letter, we have 5 take away 2, which leaves us with 3 letters to choose from for the third letter. And in the same way, once we've chosen our first, second, and third letter, we have 5 take away 3, which is 2 letters left to choose from for the fourth letter. And once we have chosen our fourth letter, we've chosen 1, 2, 3, 4 letters altogether, and 5 take away 4 leaves us with 1 letter to choose from for the last letter. And 5 times 4 times 3 times 2 times 1 is 120 ways. So there's 120 ways that we can arrange the letters of the word modal. So this is actually 5 factorial. Part 2. How many of these arrangements begin with L? So again, I have 1, 2, 3, 4, 5 boxes. The first box represents the first letter, second box represents the second letter, and so on. So we want the arrangements to begin with L. So I have an L drawn in there underneath the first letter. So if we choose L for the first letter, we have a look and we see, well, how many L's did we actually have in our word? There was only one L. So we've only one choice of letter for the first letter if we want it to be an L. Once we've used the L, so remember the L has to go first, we've 4 letters left to choose from for the second letter. And when we move on to the third letter, well, we've used 2 letters so far. So 5 take away 2 leaves us with 3 letters to choose from for the third letter. When we move on to the fourth letter, we've already chosen 3 letters. So 5 take away 3 leaves us with 2 letters left to choose from for the fourth letter. And when we move on to the fifth and final letter, we've already used 1, 2, 3, 4 letters. 5 take away 4 leaves us with 1 letter to choose from for the fifth letter. And the question said how many, so we multiply 1 times 4 times 3 times 2 times 1, and we get 24. So there's 24 arrangements that begin with the letter L. Part 3. How many do not begin with L? So how many of these arrangements do not begin with L? Well, in part 1, we worked out that there was 120 ways in total that we can arrange the letters of the word modal. In part 2, we worked out that there were 24 ways we could arrange the word modal that began with an L. So we want to figure out how many ways we can arrange the word modal so that we do not begin with an L. Well, if we do 120, take away 24, that will leave us with the amount of ways that we can arrange the word modal so that we do not begin with L. And that leaves us with 96, because 120 take away 24 is 96. There's 96 ways we can arrange the letters of the word modal so that we do not begin with an L. Now there is another way to do this, it's just a little bit longer, but it's using our box method. So we set up our 5 boxes and we have multiplication symbols in between. So we want the first letter to not be L. So the question says how many do not begin with an L? We want our first letter to not be L. So in the word modal, the letters that are not L are M, O, D, and A. So there's 4 letters to choose from that are not L. Now, once we've chosen our first letter, it doesn't matter what it is, so long as it's not L, we then have 4 letters to choose from for the second letter. When we move on to the third letter, we've already chosen our first and second letter, and 5 take away 2 leaves us with 3 letters to choose from for the third letter. When we move on to the fourth letter, we've already chosen our first, second, and third letter, and 5 take away 3 leaves us with 2 letters to choose from for the fourth letter. And once we moved on to the fifth and final letter, we've already chosen 1, 2, 3, 4 letters, and 5 take away 4 leaves us with 1 letter to choose from for the fifth and final letter. And 4 times 4 times 3 times 2 times 1 gives us 96. So you can choose whichever method you want to work out question 3. The second one is obviously a little bit longer. Question 4. How many end with M? So remember, the word modal has 5 letters, M-O-D-A-L. So we've got 5 boxes and we've got multiplication symbols in between each. And we want to know how many arrangements end with M. So the 5th letter is the last letter. So we want that to be M. We want the arrangements to end with M. So looking at the word modal, there's only one M. So we've only one choice for the 5th and final letter. So that definitely has to be an M. So there's only one M. So 1 has to go in the last box. Now, once we've used M, we know that the M is going at the very end. We have O, D, A, and L to choose from for the first letter. We've 4 letters left to choose from for the first letter. When we move on to choose the second letter, Well, we've already chosen the first and the last letter, so that's 2 letters already chosen, and 5 take away 2 leaves us with 3 letters to choose from for the second letter. When we move on to the third letter, we've already used the first, the second, and the last letter, so that's 3 letters used. So 5 take away 3 leaves us with 2 letters to choose from for the third letter. When we move on to the fourth letter, that we've already chosen the first, the second, the third, and the fifth letter, so that's 4 letters already chosen. So 5 take away 4 leaves us with 1 letter left to choose from for the fourth letter. And 4 by 3 by 2 by 1 by 1 gives us 24 ways that we can arrange the letters of the word modal so that they end with M.